In this video, we'll generate a trend line and polynomial of the ATANH function. We begin with the dataset. So array formula, ATANH inverse hyperbolic tangent of the x values. And we'll chart this. Insert chart. And we'll use scatter chart. Use row 1 as header. And for the series, the vertical axis, we show the axis line, the number format, none. And for the horizontal axis, also the number format, none. We'll continue with the Taylor-Maclaurin series sum in two forms. Starting with the first one, which is the summation of a1 times x to the power 2n plus 1, where the value of n is from 0 to infinity, and the value of a1 is 1 over 2n plus 1. So our n will be from 0 to infinity. But 16 is good enough as approximation. And the coefficient, so array formula, 1 over the quantity 2 times n plus 1. And the Taylor-Maclaurin series sum, array formula, series sum of the x values raised to the power 2n plus 1. So 2n plus 1, n equals 0. That is 2 times 0, 0, plus 1, 1. So the starting point is 1. And the increment, so we have, after that will be 2 times 1 plus 1, 3, 1, 3, 5, 7, 9. So the increment is 2. And the coefficient, it will be this range. And the second part, which is using the n equals 1 to infinity. So it's a summation of a2 times x to the power 2n minus 1. And a2 is 1 over 2n minus 1, while n starts from 1 to infinity. So we start from 1. So this is equal to our formula, 1 over the quantity 2 times n. Our n will be 1, starting from 1, minus 1. Enter. Now the series sum. So array formula of the x series sum of the x values raised to the power 2n minus 1. So at n equals 0, n equals 1, 2, minus 1, 1. So the starting point is 1. Next, 2 times 2, 4. So at n, 2 times 2 is 4, plus 1, 5. So 5 minus 1, 3. 2 times 1 equals 2. 2 times 2 equals 4. Minus 1 is 3. So 3, 5, 7, 9. So the increment is still 2. And the coefficient, it will be this range until 1. And we modify the chart to show the trend line series. For the yellow, because there's no yellow, we change that to green because this is green. And the series show the trend line polynomial to the 8th degree. For the label, use the equation. For the legend, position at the bottom. And here is our trend line and the polynomials of each trend line. We'll calculate this polynomial regression coefficient using LINEST. To do that, we use the LINEST matrix, starting with the power. Transpose 0 to 8. And the elements of the matrix are a formula of the x values raised to the power 0 to 8. Now we calculate the polynomial regression coefficient. So LINEST data y comma data x. That's for the ATANH. Now the first Taylor-Maclaurin series sum. So LINEST, the first expansion data y and data x comma data x. And finally the second expansion, which is LINEST data y comma data x. And we'll compare our polynomial regression coefficients with this in the polynomials. Coefficient of x to the 0, 0. Coefficient of x, 0.999. Coefficient of x squared, 0. Coefficient of x cubed, 0.355. Coefficient of x to the 4th, 0. Coefficient of x to the 5th, 0.0355. Coefficient of x to the 6th, 0. Coefficient of x to the 7th, 0.0504. 504. And coefficient of x to the 8th, 0. So we can use this expansion and also or this expansion. We still get the same results. This completes the use of array formula, data validation, LINEST polynomial regression in the Taylor-Maclaurin series sum expansion of the inverse hyperbolic tangent.